Hello, Fermi and friends. Welcome to the first stream of 2024. This is the first Live Code Tuesdays of this year. My name is Sohan Maheshwar. I'm a dev advocate at Fermion. And for the first time on Live Code Tuesdays, we have Caleb. Hey, Caleb.
Hey, how you doing?
So, Caleb, thanks for joining in. For the first stream of 2024, we thought, hey, why not actually just do a deep dive on all
Mhm.
things WebAssembly, right? So I'm sure you already know stuff about WebAssembly and how it works, but Caleb here actually did a great presentation in Chicago, I think it was, right, Caleb?
Yes, correct.
Yeah, about a deep dive into how WebAssembly actually works. So we're really getting into the nuts and bolts of things. Before that, yeah, let us know where you're watching this from. I see David here. David is a regular viewer, and David will also hopefully be joining us on a live stream very soon. Hey,
Mhm.
David from Dallas. Thanks for joining in. And yeah, we have a few others on the stream as well. So welcome. Bunny is here
Nice,
from
Boulder
Boulder
County.
County. Yeah, awesome. Cool. Caleb, let's just go straight into it, right? So today we are going to do a deep dive into WebAssembly and talk about what actually is WebAssembly. And I have a feeling our viewers might know what we're going to talk about, but this is like a real deep dive, right?
Absolutely. Yeah, go right to first principles for WebAssembly.
Nice. So you know what? Let's just get started, Caleb. I'll pull up your screen and you can take it from here.
Cool, awesome. Well, I want to say first of all, I didn't put together that this is the first live stream of the year, so it's such an honor to be on the first live stream of 2024. But yeah, let's dive right in. So this is a talk I gave at Cloud Native Rejects in Chicago right before KubeCon, and so that was super exciting for me. It was my first conference talk, and I'm excited to kind of share a version of that with everybody here. So we're going to be talking what is actually WebAssembly, and let me just skip through a bunch of the intro stuff here I did for the presentation in Chicago. But I like to start this talk off with kind of talking about some of the things you've maybe heard about WebAssembly in the popular media and kind of the popular conception of what WebAssembly is. And so, there's a number of things. First of all, WebAssembly is super popular. It's all the hype. I'm sure, we're talking about it all the time. It's on podcasts everywhere. There's YouTube videos being released about it all the time. And you've likely run across the textbook definition of WebAssembly, which is this kind of like really verbose, complicated, dense sentence that we're not even going to bother reading. But hopefully by the end of this, we'll be able to kind of break apart all the little parts in this, verbose, dense description and understand what they mean. I'm sure the people here know WebAssembly is the same as Wasm. It's just an abbreviation for that. People talk about that a lot. And WebAssembly is being used all over the place. So here at Fermion, we're really excited about WebAssembly on the server side. And it's also being used in the browser. It's being used in plugins, blockchains, databases, really all over. And another thing people are talking about in the media with WebAssembly is how it's getting major adoption. Big companies, Google, Microsoft, maybe someday Fermion will be a big company on that adoption list, things like that. And then lastly, and I think most importantly, people who talk about WebAssembly are always talking about four properties that WebAssembly has. First one is security, and they talk about how you know WebAssembly offers a sandboxed execution environment. So we'll break down later what that means. People also talk about the performance that WebAssembly gives, near native execution speed. Again, we'll break that down later. They use this word polyglot, which is, I think, kind of a terrible word because it's hard to understand what it means. But poly, many, and glot, language. WebAssembly supports multiple different languages. And then portability. It offers this kind of cross-platform, cross-architecture story. So those are some things you hear about WebAssembly in the popular media, but really the whole thing I want to do here is take a step back and be like, okay, this is all the hype and buzz we hear about it, but what actually is WebAssembly? Like, what's the actual tech underlying all of this? So that's what we're gonna do. We're gonna dive in right away here. Just before we do that, I'm a big fan of like really cheesy animations in PowerPoints. So with a little bit of help of like
Yes.
in animations,
Yes, I love it. Yeah, I love it.
um, we're going to be calling back to these four properties about WebAssembly. And so this was actually some advice I received from Sohan of, it's really important to kind of tie these technical concepts we're going to be talking about to the underlying reasons why we would want to care about this technology. So keep your eyes peeled for these little stamps appearing on the slideshow, and we'll call back to these things. Great. So doesn't look like we have any questions, so I'll keep diving in here. First things first, what is WebAssembly? Put most simply, WebAssembly is just another bytecode format. So if you've ever done any Java programming, you might be kind of familiar with what that means. So if you have a Java program, you would take that, you'd write your program, you would compile it to a Java bytecode, this kind of intermediate format that can't be directly executed by a computer. And so you use something called the JVM, the Java virtual machine, to execute that Java bytecode and actually run your program. And this JVM can be compiled to run on, an ARM machine, an x86 machine, a RISC-V machine, et cetera, et cetera. And so, that's kind of what a bytecode is, this intermediate form that you compile to and then can be run on a virtual machine in any computing environment. WebAssembly is really similar to that. So you take your program in any language, you compile that program to WebAssembly, a WebAssembly bytecode, and then you execute that WebAssembly on a WebAssembly runtime. Similar to Java, that WebAssembly runtime can be built to run on different architectures, ARM, x86, etc. And so it's that kind of mental model. This is how you should think about what WebAssembly is. It's a bytecode. And so immediately I want to call back to kind of two of the things we talked about. The first one is this kind of polyglot programming, the ability to support multiple languages. So you'll see here, we're talking about any program can compile to WebAssembly. Not quite any, but the list is growing, and it's a pretty big list already. And we have a bit of that polyglot story. Previously with Java, you have Scala and Kotlin, a number of different languages that can go to a Java bytecode. But WebAssembly offers that even kind of wider array of things that can go down to Wasm bytecode. Second thing I want to point out is that with the Wasm runtime, you get this kind of portability story across architecture, cross system. If you are able to build just a few Wasm runtimes that can cover the gamut of Windows and Mac and embedded systems and browser and server side, maybe you have to build like 3 or 4 runtimes. All of a sudden, anything you write can be run anywhere. And so it's kind of this I like to think of it as this extension of the write once, run anywhere story that Java was trying to tell, of being able to write code once and run it anywhere, and doing that kind of better in some ways.
Yeah. So I have a question for you, Caleb. And typically when I speak about WebAssembly at like meetups and conferences, this is the sort of first question that everyone asks me, right? Mm-hmm. So what really is the difference between, say, like a JVM and like a Wasm runtime? And before you answer that, welcome Vamshi to the show. David, I hope my volume is slightly better. Boosted the gain on the old portable mic that I'm using. Nice. So let me know if that's okay. Over to you, Caleb.
Yeah, that's a great question. And, it's really something that comes up a lot, I feel like, when we talk about WebAssembly. I think there's a couple things that make it different. In some ways, you could imagine extending the Java bytecode format to suit the needs that we're trying to make possible with WebAssembly. In practice, that's really difficult to move kind of a project that's existed so long and change a number of things. And there's a number of things that we did want to change. So, security is one of the things that, with Java bytecode, it's completely open by default, whereas we'll talk later about this, but WebAssembly used closed by default, denied by default security standards, which are just kind of more modern practices. Another example is, the Java bytecode is really baked into the assumptions of Java itself. So it has concepts of like classes and things like that don't translate very well across multiple different programming languages. And so Wasm was kind of this like nice, fresh restart where we could have a more generic bytecode format that kind of just worked better.
Nice. Yeah, I find that part, I think, the most interesting, that JVM is typically like tied to the notion of Java, which is also owned by a corporation and all of that. Whereas, with Wasm, it's a completely different way of thinking around those lines, right? Yeah, absolutely. Yeah.
Totally. Cool. So WebAssembly, it's a bytecode format. We're going to kind of talk about the 3 parts here. So this WebAssembly bytecode in the middle there, that's what we call the WebAssembly module. And that's the first thing we're going to dive into, understanding what does a WebAssembly module look like, all those kind of things. We're also going to spend some time talking about, hey, I've got my program. How do I actually get that program into a WebAssembly module? What does that compilation look like? And then we're also going to spend some time at the end kind of talking about, great, I've got my WebAssembly module. What does it actually mean to execute that? What are the runtimes like? Where can I run it? Things like that. So diving into, what a WebAssembly module is, first I want to kind of share that a WebAssembly module has two representations. So the first representation is the binary format. In the wild, this is like typically the format of WebAssembly that you're going to see. It's just kind of the representation of a WebAssembly module in just bytes. It's the most compact format. And that's why you tend to see it the most in the wild. This is what we're going to be using at Fermyon because it's the cheapest to send over the wire. It's the quickest to interpret all these kind of different things. .wasm is the extension that you'll see for that type, that format on disk. The other format is a text format. Because I don't know about you guys, but like I haven't quite yet mastered the ability to just like look at these bytes and understand what that means. So thankfully,
we should do a stream where like we try and write code as a .wasm.
Yeah. The next half an hour, me just typing out bytes of a WebAssembly module. So thankfully they have this completely equivalent format called the text format. That's just the same thing, just a textual representation of the same module. And it has the extension .wat. In practice, like, unless you're kind of playing around or like debugging something, nobody uses wat, but it's like really useful for those kind of debugging use cases, or if you're like a compiler engineer, things like that. Actually kind of understanding the text format. So, the text format is composed of something called S expressions, which we're not going to go too deeply into because we'll end up in like a history lesson about Lisp and it would be a little off track. But if you're into it, I highly recommend kind of exploring. But really all an S expression is a way of representing this kind of hierarchical tree-like data in a textual format, right? So text is just this kind of like flat format. How do we represent this tree? And so that's with S expressions. And so an S expression is like parentheses, and then you've got like the node, the root of the tree as the first thing. So modules are like the root of the tree, and then it has two children, this tree and this tree are its two children. And then, func is the root of this tree, and et cetera, et cetera. It kind of goes on and on. And so, this is how we kind of build up this representation of, modules have functions, and functions have names and parameters have types and names, etc. So that's all I'll say about, S expressions, but it's kind of a cool aside there. So diving in, here we go. We have our first, WASM module, super exciting. We have parenthesis module parenthesis. And this is actually the simplest, WebAssembly module that actual compile. So doesn't do anything, but it's kind of building up from the ground to start.
Yeah. Imagine seeing an error when you write this program, right?
Yes.
Like, parentheses, still found an error.
Yeah. Forgot the semicolon.
Yeah.
So that's the most basic one, but it's a little bit boring. So let's build it up a bit. So the first thing we can add to a WebAssembly module is functions. So a WebAssembly module can have functions. So here we've got a module. It's got two functions. One's called add, one's called +1. The add function takes in like two parameters called left-hand side and right-hand side, which are 32-bit integers. And it says, I'm going to return a single 32-bit integer. It's got three instructions in that function. We'll get into these instructions in a second. And we've got another function here called +1. Takes in X and returns a 32-bit integer. Again, we'll get into the instructions, but I want to note, notice how this is calling out to this other function that we have add here, so they can reference each other. And maybe one way to kind of think about this module is like if you had like a Rust program, for example, that had a function add and a function +1. This is kind of what that Rust program would compile down to in WebAssembly. Now, I'm a big graphical guy, so I've got graphics here of what these WebAssembly modules look like. And so this WebAssembly module that we just defined, that's this purple box here. And so we've got our function add we talked about. We've got our function +1 we talked about. We've got this reference between these functions, so these kind of entities can be self-referential in there. And then we can see that this, guest WASM module is living inside this host runtime. And so this is where I like to like pause and be like, whoa, what is this like host guest terminology? Because when I started working at Fermyon, I was like still pretty new to WebAssembly, and this was my reaction. I was like, why everybody keeps saying host and guest? Like, what do they mean? What's going on? So it's actually really simple. When you see host, I just want you to substitute that in your head for just like runtime. That's just the terminology we use for like the runtime, the thing executing the WebAssembly. And when you hear guest, I literally just want you to substitute like Wasm module. That's just the terminology we use for Wasm module. So in some ways, we don't even really need that kind of as a prefix, but I put that there because we use that terminology so much in the ecosystem. So, simple, host is the runtime, guest is the Wasm module. Why do we use this terminology then? I think it's kind of helpful to like think of an analogy, this kind of metaphor for why we use this. That actually one of the engineers on our team, Brian, helped me come up with. So, think of the host runtime as kind of like a hotel, and think of like the guest Wasm module as like a guest coming into that hotel. As the guest, you check into the hotel and you get access to your room, and maybe you get access to like a shared pool, and you can go to the buffet and things like that. But as a guest, you don't have access to like another guest's room. Like you don't have a key to get in there. You don't have access to the kitchen. You don't have access to like the luggage storage or things like that. And so really this like host guest terminology in my mind is a way of like saying like the host is like this trusted environment and the guest has like limited privileges within that environment. So I see
I think that's a
Michelle.
great analogy. Yeah.
I see Michelle saying here it took her a while to get used to the guest host too. Perfect. Cool. Okay, so we've got this WebAssembly module, and we've got those instructions I was alluding to. But before we can really understand what those instructions are doing, how it's like executing that code, first thing we need to understand is that WebAssembly bytecode is like encoded for a stack-based virtual machine. So that was a mouthful. Let's break that down and understand what that means. We're going to be doing a little computer sciencey stuff here for a second. So a stack machine is just a way of representing computation, where you can represent computation by pushing values onto a stack and popping values off of the stack. So taking a look at this add function, I think, is going to be really illustrative of what that kind of means. So let's say somebody calls the add function. We're going to have the left-hand side and right-hand side parameters passed in. The first instruction is local.get left-hand side, which is going to say, hey, go get the value of the left-hand side parameter and push that value onto the stack. So we'll push the value of 4 onto the stack, right? Imagining if we called with 4 and 3 as the parameters. Then we'll execute the next instruction, which is saying, hey, go get the value of the right-hand side, push that onto the stack. Then we've got this next operation here, which is i32.add, which is saying, I expect there to be two 32-bit integers on the stack. I'm going to pop those values off the stack. I'm going to add them together, and then I'm going to push the result back onto the stack. So we would expect these to pop off, add to 7, and push back 7 on the stack. Great. So we've executed all the instructions in the function. Now I want to point, we remember that this function is expecting to return a result of a 32-bit integer. And the way returns kind of work in these like stack-based functions is it just expects that that value is still on the stack. So we get here, and then whatever was calling that would be able to get the result of 7, which is sitting on the stack there. Awesome. Any questions? I want to pause here for some space.
Yeah. David says this reminds me of when I used to work on mobile agent frameworks. Tell us more, David. I'm actually not super familiar with this, but I assume it's some sort of similar bytecode type thing as well. But we'd love to hear more. For those of you all just joining in, I see a bunch just joined in actually. We're doing a deep dive on WebAssembly, and Caleb here is actually talking about what actually WebAssembly is, right? We've heard that it is secure and it's performant. You can do polyglot programming and it's portable, but what do those things really mean and how does it work? So Caleb's taking us through some of these things. Yeah.
Awesome. Cool. Mobile agents would jump to server where data was. I see. Like moving the code around to the spot where it makes sense.
Not super familiar with this, but yeah, sounds. I can see an analogy there with That oh, the question that I think everyone's thinking of, which is can it play Doom? Also, thanks for stopping by, Richard. Yeah,
Awesome.
yeah,
Yeah, I remember early in the days of WebAssembly, there was like so many game examples.
yeah.
But Butcher wishes I had been one of his CS pros. Well, maybe we can make that happen. We'll set up a time, Butcher. That's awesome. Cool. Okay. So, that's kind of an example of what a stack machine looks like. We'll just do the one example here, but you can imagine, all sorts of different operations, subtractions, or calling other functions. You'd get the result and push that onto the stack. Fundamentally, all the instructions in WebAssembly boil down to doing some sort of operation and pushing or popping values off the stack. The stamps are back. I love it. The spinning animations. So, this is a great time, I think, to talk about kind of the performance of WebAssembly and specifically kind of this claim of like near native execution speed. So we just talked about how every instruction in WebAssembly is stack based. If we were to, as just kind of a fun project, maybe we should do this as a live stream in the future. Maybe it's too ambitious. I don't know. But sit down and, spend 2 hours building a really simple stack machine that like emulates a stack machine, reads through the instructions, and emulates popping and pushing and popping values off the stack. That would be like a way to execute WebAssembly, but it would not be very performant. That's not a super high speed way to execute WebAssembly. So, some do that because that's the right trade-off. It's, simple to build an interpreter like that, and maybe for an embedded use case. But in practice, for like WebAssembly uses in the browser or server side, we want something much more performant. And so what we do in practice, some of the kind of premier WebAssembly runtimes, Wasm time is an example of this. What they do is they take this WebAssembly code and they transpile this kind of like stack-based representation of the code into this intermediate format that depends on the different runtime they're using, that, is a better representation for how they're going to execute the code. And then they take this intermediate format and then they JIT compile that, which just means to like on the fly generate machine code to actually be executed by the machine. And so, this is kind of a whole other topic that we could tangent on, so we'll leave it alone for now. But this is how we kind of get this near native execution speed with WebAssembly, is because we're JIT compiling it to machine code to directly execute.
Got it. Because a ton of articles about WebAssembly just say, oh, it is performant because of the stack machine, right? Because of the way that it's actually built. But I think it makes sense that it is JIT compiled to the machine code, which sort of gives you that near native performance. So, yeah.
Totally. Well, and the WebAssembly spec actually like talks about one of the goals being having the bytecode be a representation that's like closely analogous to something that can be like JIT compiled and executed, so you can get those near native execution speeds. But yeah, it's not the stack machine that's the performant, which is kind of the tricky part about it.
Yeah.
Awesome.
Richard
Do we got some more
says,
comments here?
Yeah, I can't wait for the lead code interview question that says, write a stack machine that plays Doom. Next year's advent of spin, I guess, or advent of code, probably, Richard.
Yeah, I like it.
Yeah. Also, is this the Richard Boyd from the DevRel world, Richard Boyd? Because then we might have been colleagues sometime in the past.
Ooh, small world.
Small world.
I love it. Cool. Okay, so speaking of small worlds, here's the state of the world. We've got our Wasm module with its functions in the host runtime. Oh, look at that. They were colleagues. Awesome.
Oh, nice.
But we got a problem. We've got these functions, but this is us. This is me. This is us trying to access the stuff in the WebAssembly module. We can't access it. There's no way to access these functions, which is kind of a bummer because that's pretty useless. Thankfully, WebAssembly gives us a way to export functionality. And so, it's pretty simple. We've got this add function from before, and then we've got this kind of like export clause, which is saying export something with the name Wasm add, export it as the name Wasm add. And what are you exporting? We're exporting this internal function we just defined, add. So again, what does this look like in a diagram? This is what it looks like. Got your guest module. It's got the function add. We're exporting it to this thing named Wasm add. And now this is something that can be accessed and invoked by the function. right? The external user has access to talk to the runtime. That's like you calling, a WebAssembly API in JavaScript, um, or things like that, or invoking something on the command line with Wasm time. But you don't have access to directly go into the guest Wasm module, which is why you need to do this export. Awesome.
Yeah. Quickly, Caleb, we have a question from Richard, who asks, could it actually be real compiled, or like a native compilation, I'm assuming, so that you don't have to pay any just-in-time penalties?
Yeah, that's a good question. So, Butcher has a bit of an answer here that Wasm time can AOT compile to a native format, and so that's what I was going to say. Of that, you can, in the sense that if you know the architecture you're going to, you can just it's like it's AOT because you're JIT compiling, but you're just doing it before because you want to do it already. The reason that we're able to do that because we run it server side and we know the systems and architectures where we're going to be executing that code. In more generic use cases, like in the browser, they're not you can't ship WebAssembly to the browser and expect that to run if it's pre-compiled because you don't know what architecture that computer is going to be running, kind of thing. So it's a trade-off there.
Oh yeah, thanks, Bunny. Sorry, I should have mentioned AOT is ahead of time, where you sort of, like Caleb said, the architecture, the OS, and the compilation is optimized for that versus just-in-time or JIT. And I fully agree with you. I think most computer science nowadays is magic to me, at least to a boomer like me. I'm like, whoa, all of this works so well. How does this
Yes.
happen? Yeah, so, well, luckily we have people like Caleb who can explain things to us. So
Well, and that's how I feel working here at Fermion with all the people working upstream. They say all these magic WebAssembly words, and then I try and glean a few things and bring them down for everybody. Awesome. So kind of diving back in here, we've got this function, we can export it. But not only can you export functionality in a WebAssembly module, this is where things start to get really exciting, but you can also import functionality into a WebAssembly module. So first, let's understand, what is this code saying? And then we're going to kind of understand at a higher level, why does this matter? Why do we care about this? So we've got a import statement here, and it's saying import from the console log namespace a function with the signature, print. It's called print, and it takes in a 32-bit integer. So just a function that prints the number that you pass to it. And then we can define our own function called print number that takes in an integer. We, get that parameter and push it onto the stack like we saw earlier, and then we call print, this function that we just imported. So let's look at the kind of visual, aspect of that. This is, the external user supplying an implementation of this function in the console log namespace. So a function that prints the number. It's being imported as print internally in the Wasm module. And then we have our own function that calls and references that print. So, really simplifying this, we imported a way to print a number. Pretty exciting. But if you actually stop and think about this, it is really important and it is really exciting that you can import things into a WebAssembly module, because all a WebAssembly module can do without imports is really basic computation. It can do your addition, your subtraction. It can do if statements and call functions and control loops and things like that. But it's not able to print to the terminal. It's not able to read from the file system. It's not able to access a microphone or access environment variables. All these kind of things you actually want to do when you're writing a program and interacting with a computer. But thankfully, we have this interface to be able to import functionality such that you can still do these things. And so that's how you supply the ability to access an environment variable, write to disk, things like that, by importing this functionality. Awesome. I see we have a comment from Richard Boyd here. Yeah. Well, and I don't actually know the answer to this for sure, but I wonder if you might not be able to for Lambda just because you don't necessarily know the architecture it's running on, but maybe you do. That'd be, I don't know the answer to that.
Yeah, I'm not sure either. Yeah.
Awesome. So we've got the imports here, and we were able to export functionality. There's a ton of different parts to a WebAssembly module, but the kind of biggest and last important one I want to talk about here is shared linear memory. which is a mouthful. So we're going to start by breaking that down. Memory. What is memory? Well, in a program, when it starts to get more complex, you start to have strings and objects, these kind of bigger things that you don't want to be storing directly on the stack of the program. And so you want to put it in the heap. Ignoring the kind of computer science terminology, you need memory in a program to store these kind of bigger objects. So memory is just memory. Same thing in WebAssembly. Why do we call it linear memory? Well, we call it linear memory because when you instantiate a WebAssembly module, you're given one contiguous block of memory, and it's not fractured throughout the system. It's guaranteed to be a continuous sequence of bytes that you have access to. And then lastly, why do we call it shared linear memory? It's called shared linear memory because not only can this, guest Wasm module have access to its own memory, but the host can also have access to the same memory. And you could theoretically have other Wasm modules that are running having access to the same memory. So you can kind of like do shared memory between different WebAssembly modules if you so choose, or the runtime, and communicate through this memory. So we'll see what that looks like in a diagram form soon. Kind of breaking down, the code here, the actual module. We're again importing a console log function from supplied from an external user. This one's a little different. It's taking in an integer, 2 integers, and that's saying what's the index of the memory I should read into and how many bytes should I read, and I'll print off whatever's in memory at that kind of like range that you've passed me. And here we're saying import from the sysmem namespace a block of memory. And so I forget if it's block or page, actually. I think it's page, 1 page of memory. And so 1 page of memory is 64 kilobytes in the world of WebAssembly. Then we're saying on line 4, initialize. So data is saying initialize into the 0th index, the string hello world. So we're saying like write hello world into memory right at the start of it. If anybody's worked in assembly before, this is kind of like a static section in your binary, inserting data into that. Then we define our own function that says, push 0, the index into the memory onto the stack, 14, because there's 14 bytes in hello world, and then call this log function we've imported, which will then go into this memory, read the 14 bytes out, and print out hello world. So this is just kind of a really simple hello world. And of course, we need to export the hello world function so it can be executed. So here we go. This is the awesome diagram. We've got, the user supplying us this console log so that we're able to print. We're using this internally to do our hello world function, which is pushing the 0 and 14 indexes to print hello world, and we're exporting that so they can call it. And then you'll notice how both the WebAssembly module has access to this shared linear memory. It's initializing hello world into it. But also this function written by this external user has access to the shared linear memory. And so that's how we're kind of able to communicate across this boundary of the guest. Awesome.
Nice. For the folks just joining in, again, a quick recap. We're doing a sort of deep dive on WebAssembly and how it works and why it does the things it does and why its performance is so good. Caleb here right now is talking about one WebAssembly module, how it works in a WebAssembly runtime, how it can import and export certain things as well. And yeah, this is the first Live Code Tuesday of 2024, and hence we thought it would be appropriate to actually start off with a deep dive on WebAssembly. We have a question from Bunny, which is regarding AOT compile for X but not Y. As far as I know, AOT compilation is just old school compilation. You multi-target compile and get multiple binaries, one for each target. Interesting. Okay. My understanding always was that you sort of ahead of time optimize for the target that you're going to compile to, as opposed to compiling it to multiple different ones. I'm not sure. I could be mistaken though.
Yeah. Well, I think Bunny's correct here. Although we're just getting into the kind of nuanced land of like, you can do this, ahead of time compilation to all the different targets with WebAssembly. And in certain use cases, it makes sense. But, in certain ways, this is kind of the whole story we're trying to avoid with WebAssembly, where, you do get that near native execution speed by keeping it in that intermediate format and just compiling it on the fly. So definitely an interesting space though. And that's where a lot of, room for optimization is. Awesome. So here we've got this diagram, this Wasm module, this guest living in this host runtime. We're using the shared linear memory to communicate, and more stamps, more flying animation. So exciting. This is like the perfect slide to kind of talk about the sandboxed execution environment and the security properties of WebAssembly. So there's really two big things I want to get across here. The first big thing is that WebAssembly is denied by default compared to a lot of other systems and architectures. For example, in the world of containers, it's not really denied by default. By default, you can do whatever you want in the container. You can access any part of the file system. You can call anybody on the network. You have access to all the environment variables. That's not the case in WebAssembly. As you've seen so far, to get any sort of like functionality on the system, you very explicitly have to say, I would please like access to import a console log function. I would please like access to a function so that I can write to the file system, things like that. So it's really like opt-in instead of like just getting access to everything by default, which is just a more secure stance and also kind of helps with being able to audit, what is a guest Wasm module doing. Second thing I kind of want to like bring home as a point is the kind of like sandbox nature of this. So we've got this guest Wasm module, and let's imagine that this is like a bad actor. Somebody tried to put a virus in this WebAssembly module, and we're Fermion executing this WebAssembly module, and we don't necessarily trust what is in here. The way that WebAssembly has been designed is that this runtime is acting as a sandbox. So the semantics of WebAssembly say that the Wasm module is never going to be able to read outside of this shared linear memory, because if it was able to, it'd be able to compromise the underlying system, right? Imagine this white background is this like server that we're running the runtime on. It's not able to do that. It's not able to break out of the shared linear memory because of the semantics of WebAssembly. And, just a number of things like that, where the host runtime is kind of designed as the secure boundary of something WebAssembly can't break out of. So, those are really kind of just the basics of what a WebAssembly module is. Oh, yeah,
Okay.
go ahead, hop in.
No, yeah, I mean, I think we have like a bunch more to talk about as well. So I was just smiling at the fact that we went pretty deep into the weeds about like how WebAssembly module works and stuff, and that's just the basics,
Yes.
there's still a lot more.
Oh, yes. Yeah. Well, no, it's true. It's crazy. Like, we talked about like, functions, exports, linear memory, things like that, but there's still globals and tables for like function pointers and things like that, which are really to kind of just make a WebAssembly module this more fleshed out concept so that it can represent all these different kinds of languages. But the really meaty, really important parts, I feel like we've covered. So if you're like really excited about this WebAssembly module stuff, my advice, and maybe we can get the link and put it in the links of the chat here. My advice is go read the Mozilla Developer Network docs. They have like great docs that kind of go through what a WebAssembly module is and how that's built up, similar to what I did here. And then also, if you're really hardcore, I actually recommend going and reading the WebAssembly spec. I know that sounds really scary, but like it's actually really well written. And if you just read kind of the like intro sections to each chapter, it will teach you a lot. And then just skip the like 40 pages of like nitty gritty details about like, what does the add instruction do in the case of an overflow? Like, yeah, just ignore all that part. So yeah, that's the WebAssembly module there. And it looks like we've maybe got a link in the chat there. Yeah, perfect. WebAssembly. Awesome. Great. So we did it. We, kind of dove in and understand what a WebAssembly module is in the middle part. Now we're going to look at the end of that pipeline. How do you actually take this WebAssembly module and like execute it on a runtime? So there's 3 semantic phases, they call it, defined in the spec to executing a WebAssembly module. The first one is decoding, which is I'm a runtime. I've been handed this WebAssembly module, which is a bunch of bytes. I need to like decode and interpret that and understand that WebAssembly module into my own internal representation of the module. Kind of just like a bookkeeping step, and only super interesting if you're like building the compiler actually. Second step, and more interesting, is validation. So I have this internal representation of a WebAssembly module. I want to go through with a bunch of algorithms and make sure that it's a valid, WebAssembly module. Make sure I'm not reading out of memory. Make sure I'm not trying to access functions that aren't there. Make sure that, my functions aren't too big. All these different kind of things that make a WebAssembly module well-formed, secure, and valid. And those are all defined. The spec has like 40 pages of algorithms of like, this is how we define that a WebAssembly module is safe. Fun, cool fact. The way that WebAssembly has been designed, decoding and validation can actually be done in tandem, in parallel, which means, WebAssembly is actually a really great fit for streaming use cases because you can immediately start validating as soon as the first byte comes in. You don't have to wait to stream in the whole, 10 megabyte WebAssembly module and then start validating it. You can be validating as you stream it. Validation is also kind of important from a security perspective of it's, one more stopgap of us making sure that this WebAssembly module we're executing is well formed and conforms to the semantics of WebAssembly that make sure it's going to be safe. Then we've got execution, which is, really actually two parts. So first you instantiate a module instance, again, kind of a bookkeeping task from the compiler perspective. And then you invoke a specific function that you've exported. So you invoke that hello world function we exported, or you invoke that add function we exported, and you get the result out of the runtime. There's a bunch of popular Wasm runtimes. Since about 2017, we've had great support for WebAssembly in the browser with things like SpiderMonkey and V8. As time has gone on, we've gotten more and more runtimes across a number of different, for a bunch of different use cases. Kind of the marquee one is Wasm Time. It's something we use a lot internally here at Fermyon and contribute upstream to. It's maintained by the Bytecode Alliance. Really, kind of this marquee WebAssembly runtime. And then, but there's tons of them. One of my kind of pet ones is Wasm 3. They do some really cool stuff with how they interpret instead of JIT compile, and they're really good for embedded use cases. But really the point I'm trying to illustrate here is that like there's a wide array of runtimes that fit these wide array of use cases and really kind of offer this cross-system, cross-architecture, cross-platform portability. Great. So, we're coming home on the home stretch here. Now we're going to look at the kind of first half of this pipeline. How, I've got my program in some language. How do I actually compile that to WebAssembly that can be executed? And so, I think kind of a simple place to look at the story is Rust. It's, a language with fantastic WebAssembly support. And in languages like Rust, these kind of static compiled languages, the story in some ways can be as easy as like you flip a flag in the compiler and you make WebAssembly your target instead of like x86 machine code. And you've compiled your Rust program to WebAssembly, which then can, of course, be executed by a Wasm runtime. It gets a little bit more nuanced when you start talking about like bindings for the browser and stuff like that. But in the simplest case, it's pretty straightforward with these kind of compiled languages. And C and C++, have good support through a number of compilers like Mscript and Zig and LLVM. Perfect. So that kind of other big part of the story we need to talk about is like these dynamic interpreted languages. It's simple and straightforward. If it's a static compiled language, it's already meant to be compiled. But what do you do with something like Python or JavaScript that can't be directly compiled to WebAssembly? Well, for starters, Python as an example, you can't just directly compile Python to x86. You don't a priori know in these kind of dynamic languages what sort of machine code you should output. So the solution to this, I think, is kind of wild and really cool. What we do in practice is somebody spends a really long time figuring out how to take the Python interpreter and compile that to WebAssembly. And so that's like one time up front, we do that work and figure out how to do that. And then all of a sudden we've got the Python interpreter as a WebAssembly module. And we export the invoke function the interpret function out of that interpreter. And then when you actually want to run your Python source code as WebAssembly, you hand that Python source code as an input to the Python interpreter, which is already a WebAssembly module, and it directly executes that Python source code. So you're not so much directly compiling your Python to WebAssembly so much as you compile the interpreter to WebAssembly, and then that can run Python in a WebAssembly environment, which I thought was pretty cool.
That is pretty cool. Yeah. If I'm not mistaken, I think Python support for WebAssembly took a while in terms of like all of the feature support, but yeah, I think this is just a fantastic and very cool way to actually take like a dynamically interpreted language to it. There's a question from Chokosabe, who asks, anyone here with experience running Fermion on Hetzner Cloud? Phew, I don't know if we have any documentation or tutorials for that, but we did run Fermion platform itself on AWS, and there is some documentation for that. So I wonder if we could use that. But I don't know. Caleb, have you tried running it on Hetzner Cloud, perhaps?
Yeah, I haven't run it on Hetzner Cloud, but yeah, I mean, platform's a great answer, and I know we're doing a lot of work now to make Spin run great on Kubernetes. So if you could run a Kubernetes cluster on there, get in our Discord, and we'd love to kind of help you explore that, or even just run it directly with platform or run and Spin on there.
Yeah, I think the Kubernetes approach is something I'd probably recommend at this time, Chokosabe. I'm sure there's enough Kubernetes support on Hetzner Cloud, and we are working on a way to get Spin running on any Kubernetes cluster. There are certain ways using K3D and Run Wazi and things like that that you can explore right now as well, where the dev experience is slightly different. We do have documentation on our website for that. And again, just jump into our Discord. Here's the link. For those of y'all who haven't already, including you, Chokosabe. And yeah, we'd love to help you out as well.
Totally. You were talking about the Python support taking a while. It's a really cool story. I don't know if we've had Joel Dice on here. He's one of our engineers in Fermion. He's done amazing work in the Python and WebAssembly space to make that possible with a project called PyComponentize. And it's a really cool problem space because so many Python programs actually leverage like C underlying in their libraries. And so PyComponentize has this like difficult problem of like taking the Python interpreter and Python source code and like C source code and like linking it all together in the right way, like using components. It's a really cool space. And great work done there, great support now, but it'd be a cool thing to talk about in the future, I think.
Yeah, and shout out Joel, super nice person, also incredibly smart and knows so much about all the things about like compilation and all of that. So yeah, shout out Joel. David, yes, for sure, we will do something on Fermion and AWS and Kubernetes very soon. We also did a webinar very recently about Fermion and AKS, which is Azure Kubernetes Service. It's on the CNCF channel. It was a webinar there. But yes, point taken, we will do a stream on this very soon.
Totally. I look forward to that day. Awesome. Again, kind of just harkening back, I think this is a premier example of this kind of like polyglot programming, multi-language programming you get out of WebAssembly, where even, interpreted languages that take such a different perspective can be brought down and brought into this kind of world of WebAssembly. This is a excerpt, and admittedly, and actually an old excerpt. I think this is out of date, and there's better support than what I'm showing here, of kind of just support across all these different languages. And yeah, I mean, this just goes to show, kind of how wide the support is getting in WebAssembly. Yeah, that's pretty much the meat of the kind of sharing about WebAssembly there. I've got a reading list we can share later, and in the actual presentation, I talk a bit about Spin, but I think folks here probably know about Spin, so maybe we can save that and leave some time for questions or something like that.
Yeah, sounds good. Folks, if you have any questions about the inner workings of Wasm, feel free to ask in the chat. Also, this is the link to the WebAssembly language support matrix. This is something that we consistently update because this is an evolving space and more languages are getting better support for WebAssembly. So yeah, bookmark this page as well. Nice question, nice comment from David here, which is, I think even without Polyglot, having compiled Wasm components available from an archive repository sounds useful. Great thought, David, and this is, I think, where the component model really comes into the picture. I know there's something called WARG, WARG, I think it is, Caleb, which is
Correct.
like a
Yep.
WebAssembly registry similar to, like a Docker hub I think it's called. Is it called
Uh,
Docker Hub? No,
yes,
Docker Hub. Yeah,
similar to registries like Docker Hub or npm or
yeah,
things like that.
yeah.
Well, so I wasn't necessarily going to talk about this, but I can't help myself after that comment, David. Of well, and yes, talk a little bit about WASI. So if I go back, so people talk about WASI and talk about the component model, but like I think it can get a little complicated when people talk about it because WASI is the WebAssembly system interface, and you use it to interact with this, and then the component model kind of like steps on that because it's kind of like the new envisioning of that. Um, I want to look at it from the perspective of how we just like learned about a WebAssembly module is to understand what the component model is and what WASI is. So if you think about a WASM module, a guest, as this piece of code that can like do some work and it takes in imports and it exports function like exports things. It has inputs and outputs. That's what a component is. Technically, it's like a little bit more of a wrapping around this kind of core WebAssembly module, a little bit more machinery, but we can just ignore that for now. Just think of like a WebAssembly component model as, a WebAssembly component as like a wrapped up WASM module saying like, hey, I, take a string and count how long it is and then print how long the string is. My inputs are you need to hand me a string and you need to hand me the ability to print, and I'll export, print string length or something like that, and then you can call that. And so um, understanding it from that perspective, a WebAssembly component is just saying, hey, well, I can wrap that up and then I could put that in a registry like warg, and then somebody else could use that print string length function, or I can compose these kind of components together, and use these components interacting with each other within my program. And then WASI, the original vision of WASI was, how do we standardize this ability to import, things like printing and accessing the file system and accessing environment variables? It was really a standardization around saying like every environment's going to offer, this print function and this write and read function from the disk. But like really that's kind of been superseded in my opinion by the component model, because now it's like we can just treat those as components that you can import with that kind of functionality. And so yeah, I just think it's helpful to kind of come back to the first principles of like, okay, well, this is just like an input output machine, and so that's what a component is.
Yeah, and I think again the component model ties into so much about things like security, right?
Mhm.
If you use a component for something like authentication and authorization, and if there is a problem with the component as well, that just is one part in your entire stack. So you can just flip out that component for, get it patched or whatever, to actually, you know, change your authentication authorization without having any compromise to your business logic or to your underlying databases, or really affect your users too much as well. So I think the component model might change how we think about programming and full stack architectures and things like that because of some of this. Yeah.
I just shared a link with Sohan. He can put it in the public chat, but there's a public talk done on WASM Day by Luke Wagner, who's one of the founders and creators of WebAssembly, where he talks about the component model. And I just thought that was a stellar talk, kind of like breaking down, it's sort of like this. It's like, here's all this gibberish phrase of how we describe the component model. Okay, this is what it like actually means, and kind of paints a picture of what the future could look like. And it's really exciting.
David says maybe Wasm plus UDDI to make ephemeral services. Again, not too familiar with UDDI. I'm just going to Google that very quickly.
Yeah, I just
Oh,
did too.
universal description, discovery, and integration. Interesting. Okay. Nice.
Yeah.
Have you worked on this before, Caleb?
No,
Or
no,
are you familiar?
that's definitely new to me. But I think, it's kind of painting a similar story we talk about here internally of, once you have these components that have these clear interfaces, you can start to kind of choose where you want to run it. Maybe it makes sense to run this part of the program closer to where the data is, and this part of the program closer to the edge, and et cetera, things like that. And you just get all these really cool like security and composability benefits out of the component model once you kind of like start to componentize your programs and break them into smaller pieces.
Yeah. Folks, again, I think a couple of folks just joined in. We're doing a live stream, which is a deep dive on WebAssembly. Caleb took us through a bunch of things, including what a WebAssembly module is, how it can import and export certain things, how it runs on a WebAssembly runtime, and so on. Currently, we were just talking about the component model, which is something that was just launched, I think, in Q4 last year, 2023. And there's a lot of work that's actually going on in this space, which really is super interesting and might really change fundamentally how we build systems. So again, if you have any questions, put them in the chat. We'll be here for a few more minutes. And yeah. Okay. All right. So looks like no more questions. Caleb, any parting thoughts before we call it a day?
I don't know. Yeah, check it out. Go read the Mozilla docs if this was interesting to you. There's a lot more there to go explore and play around with Spin. Spin's amazing because it's like takes all this complex stuff and makes it easy and just kind of works. So thanks for having me.
Yeah, thank you so much, Caleb. That was great. Folks, do join our Discord as well, and we can continue the conversation there. For those of y'all who played Advent of Spin, which was our fun take on, well, Advent of Code and all of that, we will be announcing the winners next week on our live stream. We will also talk about the final challenge and also how we built some of the verification systems. We hacked it up like a day before the stream. Who are we kidding? But yeah, so do join us next week, same time, same place. Yeah, Fly, David, Bunny, Richard, Chokosabe, everyone else who joined in the stream as well. Thank you so much, and thanks again, Caleb, for joining in. And we will see you next week. Take care. Bye.